In today's video, I am going to talk to you about right triangle trigonometry. In right triangle trigonometry, there are 6 trigonometric functions. We call these 6 trigonometric functions sine, cosine, tangent, cotangent, secant, and cosecant. The way we write the sine of an angle will look like this. The way we write the cosine of an angle will look like this. The way we write the tangent of an angle will look like this. Take a closer look at what we do and how we write this. And again, feel free to write notes about this. My gift to you. The way we write the cotangent of an angle, the way we write the secant of an angle, and the way we write the cosecant of an angle. Here's how we write them all together at the same time. Feel free to take notes. I don't mind. Also, a little fun fact, I wrote this on the same page, so it's just to save paper. Save trees. For those that don't know, that little symbol that I wrote is the Greek letter theta, so in this case, sine theta. Theta is the angle, by the way. This right here is called a right triangle. You'll see I wrote hypotenuse, adjacent angle, and opposite angle. For a further demonstration, I'm going to be taking out my purple pen. Side note, whenever you're doing math, always use a pencil. I'm just choosing to use a purple pen because I want to show an illustrative point. In order to find the sine of an angle, the sine of an angle equals the opposite side over the hypotenuse. This is where I use my purple pen to distinguish where the angle theta is, as well as where the opposite side is. To find the cosine of an angle is adjacent side over the hypotenuse, and the tangent of an angle equals the opposite side over the adjacent side. Feel free to pause on this section and feel free to take notes. My gift to you once again. Take note of the first letters of each of the words: sine, opposite, hypotenuse; cosine, adjacent, hypotenuse; tangent, opposite, adjacent. You'll spell the word SOHCAHTOA. You'll notice this a lot whenever we're going over trigonometry or whatever it is for right angles, or basically you'll just notice this for trigonometry. It's a very common phrase that people will probably say, oh, this is just a random island in the coast of wherever, but this is a good way to learn about the trigonometric functions and how to solve them. To find the cotangent of an angle, it'll be the adjacent side over the opposite side. To find the secant of an angle, it'll be hypotenuse over adjacent. And to find the cosecant of the angle, find the hypotenuse over the opposite side. Another side note, in the world of trigonometry, the word SOHCAHTOA is very common. However, and this alone would surprise me because I've never seen this actually be a thing. If anybody has seen this and be a thing, feel free to let me know. I've never seen anyone use the word kaoshocha, which is basically the equivalent of what cosecant, cotangent, and secant are. If anybody has any info about that and any proof of that, feel free to let me know. I would like to see that for myself. Unfortunately, I can't prove that because I don't know if that exists. So, let's have some fun. Side note, when you're finding the cotangent of an angle, it's actually the inverse of the tangent. When you're finding the secant of an angle, you're really finding the inverse of the cosine. And when you're finding the cosecant of an angle, you're really finding the inverse of the sine of the angle. It's a little fun fact, and this will help you solve any trig functions, but we'll learn that at another time. This is just a general overview of how to find trigonometric functions. If anybody wants any help to solve a trigonometric equation, feel free to comment, feel free to like this, feel free to do anything you want with this video, and I'll be happy to help you with that. More than likely, it'll be in the form of a new video. And this is one sample of what Patryk does to expand my YouTube channel. If you have any recommendations of what you would like me to do, feel free to comment, subscribe, do anything you want with this, and I'll be here to answer you. Thank you so much. Hope you all do well. See ya!